Hey everyone, how is it going? Welcome back to another exciting video about microservices. Today we are diving into the communication aspect of microservices and how we can use events to make that communication happen. Microservices have become super popular lately because they are awesome at breaking down complex applications into smaller, more manageable chunks. But with all the greatness comes some challenges. One of the key challenges in microservices setup is making sure that these services can talk to each other efficiently. In this video, we'll touch upon some of the details, where the events fit in this context, and how we can implement them in our microservice application. So let's get started. In a monolithic application, everything runs in one process and components talk to each other through method or function calls. So you create objects with code like new class name. Those components can get tightly coupled. But if you use dependency injection and reference abstractions instead of concrete objects, you can keep things more loosely coupled. When you switch from monolithic application to a microservices based one, you face a new ballgame in terms of communication mechanisms. Simply converting those in-process method calls to API or remote procedure calls for services can lead to a lot of chatter and inefficiencies in a distributed environment. It's like a whole set of challenges developers have to deal with, and it's even known as fallacies of distributed computing. It outlines the assumptions we often make when making a switch from monolithic to distributed design. A microservice-based application is essentially a distributed system, running on multiple processes or services that might be spread across different servers or hosts. Each service instance operates as a separate process, so they need to interact using inter-process communications like HTTP, AMQP or TCP, depending on what each service requires. Now here is an interesting principle the Microsoft community follows: smart endpoints and dumb pipes. This means we aim for a design that keeps the microservices loosely coupled but still internally cohesive within each service. So each service manages its own data and domain logic independently. But when it comes to coordinating multiple microservices in an end-to-end application, we would prefer to use either REST communication instead of complex protocols, or we use flexible event-driven communications instead of a centralized business process orchestrator. In a nutshell, the two most common protocols we use are HTTP, request response with resource APIs for querying, or a lightweight asynchronous messaging for communicating updates across multiple microservices. Now we can classify these communications based on various ways depending on what we are trying to achieve. First, there are two main ways they can communicate: synchronous and asynchronous. Synchronous communication is like sending a text message to a friend and waiting for their reply before you can do anything else. In this type, the client sends a request to the service and waits until it gets a response back. It's like having a little chat. You ask something and you sit there until you get the answer. The important thing is that both the client and service follow the same rhythm, so they stay in sync. Asynchronous communication is more like sending a voice message to your group of friends. You just send the message and don't really wait for a reply. Your friends will listen to it whenever they get a chance. Similarly, in this type of communication, the client doesn't wait for an immediate response. It just sends the message and moves on with its own tasks. The service will handle the message at its own pace. Another way to categorize these communication is depending on how many people or services receive the message. First one is single receiver communication. It's like sending a letter to a specific person. Only that person will read it, no one else. In this case, each request is meant for exactly one receiver or service. So when the client sends a message, it knows exactly who is going to handle it. It's like a command pattern where you give a clear command and one person executes it. The next one is multiple receivers. It's more like throwing a party and inviting all your friends. Everyone come and join the fun. In this type, a request can be processed by 0, 1 or even multiple receivers or services. It's what we call publish-subscribe mechanism in event-driven architecture. When something exciting happens, all the interested parties gets notified and can react to it. We use an event bus or a message broker that spreads the message to everyone. We'll focus on asynchronous communication part and how we can achieve it using EventBus. So, what's an EventBus? EventBus is a communication pattern used in software architecture to enable the exchange of messages between different components or services within an application or system. It acts like a centralized hub that facilitates the decoupling of various components, allowing them to interact without direct dependencies on each other. Imagine an event bus as a cool way software components or services chat with each other at a party. It's like a fancy hub that connects them, but without making any clingy besties. Here's how it would work. Different components or services can shout out exciting news, which we call events, to EventBus. And guess what? Other components can listen in and subscribe to these events, so they get all the juicy updates. The EventBus takes these announcements from events or shoutouts and passes them to interested listeners. It's like EventBus is playing the role of a friendly party host who ensures that everyone hears the right stuff. The best part is the components don't have to be best friends to share their fun news. The EventBus keeps them independent, reducing any awkwardness between them. There are few key terms to remember in this. First one is publisher. These are like the news reporters at the party. They generate the events and send them to EventBus. Subscribers. These are the eager listeners who want to hear about these specific kind of events. They sign up to the EventBus to get updates they care about. Now, event types. Events are like exciting messages. They carry data about something happening in the system. Each event has a specific type, so the subscribers can pick and choose what they want to hear and what they don't. Event handler. Think of this as a talent at the party who knows exactly how to react to each kind of news. It's like a function that deals with incoming events of a particular type. Now, some popular EventBus setups are like Azure Service Bus, RabbitMQ, Amazon SNS, or Apache Kafka. For this video, we'll be using Azure Service Bus. Azure Service Bus is a super reliable and flexible cloud-based messaging platform, an EventBus provided by Microsoft as part of the Azure Cloud Computing Services. To start with, we'll first create a Azure Service Bus. So for that, let's click on the Create Resource icon and search for Service Bus. Once Service Bus is selected, you can click on this Create option on the Service Bus tile to start creating a Service Bus. So first, we have to select the desired subscription and then we'll select the resource group. So for me, I will select this resource group and call it OC Microservices Bus. I'll keep it this one and we'll just look at the plans. So we are going to use topics, which is only available from standard plan and not in basic plan. So we'll select the standard, which is $10 for 13 million operations per month, which is quite a lot. And we'll go to next style. We'll keep this as is. So you can also put it under a virtual network to make it more secure. For now, let's keep it simple and allow public access, and we'll review and create. So let's wait for a few seconds for the service bus to be created. So now that our service bus is created, let's go to the resource and have a look. So this is our host name of the service bus, which we have created, and that's where we will be accessing it. In the context of EventBus, another two fundamental components used to manage the flow of events and messages between publisher and subscribers are queues and topics. A queue is like one-on-one conversation between EventBus and a single subscriber. It ensures that the message is processed by only one subscriber. When a publisher sends an event to the queue, it stays there until the subscriber comes and picks it up. Queues are ideal where you need a specific task to be processed only by one subscriber, and you want to guarantee that the messages are handled in the order they are received. Now imagine a queue as a neat line of party guests waiting for their favorite ice cream. Each guest gets served one by one in the order they have joined the line. No ice cream gets missed or duplicated. A topic, on the other hand, is like broadcasting channel in the EventBus. It allows a single message to be sent to multiple subscribers who are interested in a specific type of event. Publishers can send events to a topic, and all the subscribers interested in that will receive a copy of the message. So the topics are useful when you have multiple subscribers that need to react to the same type of event. For example, if you have different components in an application that needs to know when a user signs up, you can use a topic for that event. Subscribers to a topic are independent of each other, meaning that they don't affect or interfere with each other's processing of the event. They could process the event in different ways. Think of a topic as a megaphone at the party where someone shouts an exciting announcement and everyone who wants to hear gets the message. Service Bus offers queues as well as topics to handle messaging. We'll look into how we can use topics in our microservice application to implement events. Let's come to topics under entities and create a new topic for our application. So let's call it eShop EventBus. Other things, let's keep it as is. And our topic is created, where we will have to create subscriptions using which our microservices will access this EventBus. We'll come back to this later. Now let's come to our code and have a look at it. So I've made some modifications from the previous video, and I've added one more API called Basket API, which represents the shopping cart for a user, and this would be managed using this API. So in this example, I have added this Basket API, and which would be using Redis as temporary storage where the cart information would be cached. So let's just run this and see. So the application which we are using is a multi-container Docker based microservice application, which I have been building through a series of videos. If you haven't watched those videos, you can find the link up here and you can follow them as well. So in this example, I have extended it by adding one more endpoint so that we can demonstrate the inter-service communication. So we have our catalog API, which we have been using in previous videos as well, and the new endpoint, which is for the Basket API. So in catalog API, we have endpoints which are used to manage the product catalog, and Basket API is to temporarily store the basket or the cart information of a user. So let's have a quick look at the catalog API. So this is for get items. We'll just probably get one item for now, which is ID 1. So we have this item in the product catalog with ID 1, which is a black hoodie, and it has a designated price. Now let's come to basket and let's add a basket item, because initially it won't have anything. So just to emulate this scenario, we'll add an item to the cart, and now if we put the buyer ID, which is kind of the user who is trying to buy the item, so we have for that buyer ID, we have this item in the basket. Now for example, we come and update the price of this item. We make it 29. So this is updated, and now if we do a get item, we see that the price is updated. But if we come to the Basket API and we execute it, the price is still the same. So the problem we are trying to solve here is that whenever there is an update in the product catalog for the price, we want that price also to be immediately updated on the shopping cart also. Now the one approach would be to have a backend call to the service and ask the service to update the price for all the users, but that creates a dependency on this service, and depending on the availability of this service, the Basket API, the request may pass or fail, and that also makes the service coupled together. So to decouple and reduce the dependency, what we can do is have events where whenever a price is updated on a product, we raise a price changed event, and that event is captured by other services, be it Basket API or some other API, and if they want to handle that event, they can take appropriate action. So let's go back to our code. To get started with, I also have some common classes or common functionality which would be used in both the APIs or even can be used as we extend this application and more services are introduced. So that is like a common code or a framework, you can call it, which would help the services to interact with EventBus and either publish or subscribe as per the requirement. So we have few components created for this purpose. So we have a default service bus connection class which holds the service bus clients, which will actually interact with the service bus and either publish or subscribe to the service. Then we have an in-memory event subscription manager. So whichever services are subscribing to any events, so those subscriptions would be managed by this manager. So all those subscriptions or the event types and the handlers would be stored. The reference of those handlers would be stored in the subscription manager, and whenever an event occurs and that message has to be consumed by the subscription, it would invoke the handlers using the subscription manager to process those events. And then we have a service bus EventBus class which holds both the service bus connection and the subscription manager. So it acts like a bridge between these two. The service bus has a publish async method where whenever an event is published, it would create that service bus message and then send it to the service bus sender class, which is actually sending it to the topic and the subscription client. And we also have a message handler which processes any message coming to the subscription client, and then it processes the event. While processing the event, it looks up into the subscription manager and checks whether for that event we have any subscriptions. If there are any subscriptions present, then it would get the respective handler and then it would invoke the handler to do further processing. Then we have some interfaces for that, where we have an event handler interface which has a handle function and which can be implemented to provide your own custom handle functionality. Similarly, we have an integration event class which should be used to derive from whenever we are creating a custom event, and by default it creates a GUID and also the creation date of the event, and the rest of the properties can be added in our custom event. So anyways, I'll be sharing this code along with the video so you can go through the code and understand the common classes even better. And this whole example is also based on the eShop on containers provided by Microsoft. So I'll put the reference to that project as well, so you can, that's a full-scale project with lot many other services which can be a little overwhelming to understand upfront. So but then if you want to check that out, you can check the link in the description and go through that project as well. Now let's come back to our APIs. So these are all standard .NET Core implementations where I have a basket Redis repository which handles or manages the Redis connection and the data in it. I have an identity service to look up for the user, and then some settings. Now to enable integration to the EventBus, we have some methods, extension methods for adding integration services and adding EventBus. So let's come back here, look at this. So while adding integration services, it is creating the default service bus connection using the EventBus connection string. So we'll go back to our service bus to get the connection string in a while. So this is for adding the integration service, then adding the EventBus, so where we are adding a dependency injection for our in-memory subscription manager, and then we have a service bus class where it would get the service bus connection which we just set up in the previous method, and also the subscription manager, settings, and based on that it creates the new class. So we'll also enable this code once we add the product price change event handler. So we'll come to that later, and let's go to catalog API and also have a look there. So here in catalog API we will make some changes. So first let's add a new class and let's call it service instance. It will be a static class where we'll add our extension methods, and let's create a new folder for our integration events. And let's create a new folder called events where we'll add our first event, product price change integration event. So product price change integration event, and let's derive it from integration event. So let's add the reference to our EventBus library and add few properties which we want to send as part of the message. So we'll have product ID, we will have the new price, we'll also have old price, and let's enter, which would take product ID, decimal price, and decimal old price. So our class is set up, our integration event is set up, and let's create another class called catalog integration event service, which we will just use to manage our logic for sending the events. Let's have the constructor, and let's have where, and we will also have the EventBus, and let's add some properties, and so let's add some method to speed things up. So we just have published through EventBus async method, and then we just publishing this and also logging in case there is an error. So with this we have our event service which we will use to publish this, or rather publish any event. So this is like a common code. If we have more than one events in this service, we can use the same service to publish all the events through this method. Now let's come back to our service extensions and add some code there. So I'll just put some code straight away and I'll explain it to keep things faster. So we again have the same add integration service which we saw with Basket API. So similar code is set up for setting up the service bus connection. I'll just add the reference, and then we have the add event bus function which adds the subscription manager and also adds the service bus event bus, and also we are adding the reference or the dependency for catalog integration service, because we'll be using this event service in our controller to publish the event. Now here we need this catalog settings class, so let's add that. In settings folder, let's create a new folder called settings and add a new class, catalog setting. And in catalog settings we'll have two properties for our EventBus connection string and the subscription client name which we will be using for this service. So for each service we'll have a subscription client name. Like for catalog we can call it catalog as the client name. For Basket API we can call it basket, and those clients would be the ones which will receive the message whenever it is published. If you're still with me, I hope you're enjoying the video. So don't forget to hit the like button and do subscribe to the channel if you haven't done it yet. You can also follow me on Instagram at omega_cortex. Thank you. One more thing we want to do is add the call to those extension methods. So let's do that. Builder.services, add services. We'll use builder.configuration, and we have add. Now let's go to our controller. Here we don't need this configurations because we are not using it, so we can come back to program.cs and remove this. Now let's come to our controller, and this is where we would want to publish our event. Is whenever we are updating the price, we'll raise that event. So to start with, let's add the reference to our catalog service and also create a new field. Let's call it integration event service and add the field. With this done, let's come back to our update method. So we already had this part of code, whether this flag where if the old price is not same as the product price which is coming into the endpoint, then erase the event. So once we have called save, let's check the flag and create a price event where it's a product price change event with catalog item ID, the product to update price, and whatever was the old price. And then we call await integration event service and the publish method where we pass this event. So with that we are done publishing the event. So whenever there is a change in the price, this event would be generated and published to the EventBus. Now we have to make arrangements to capture this message in our Basket API. So let's come back to our Basket API and create a new folder for our integration events. So let's add here new class, and it would be the product price changed event. It's essentially the same class which we created for our catalog API. So let's just put the same code here with the 3 properties and the constructor, and also derive it from our integration event class. And now let's call, okay, actually I should put it in events, and let's move it here. So create namespace and then create another folder for handler. So if you observed, we didn't create a handler for our catalog API because that was the service which was publishing the event. So we don't need a handler there, but we need a handler here. So let's create a new class and call it product price changed integration event handler. Now this one we want to derive it from integration handler, event handler, and which would take the product price changed event integration event. So this is the event handler for this event, for our product price changed integration event. And let's implement the interface. So let's put some code to speed up things. So we have a constructor which takes in the logger and also the basket repository, and our handle method to handle the update. So let's put some code to speed things up. So this is our handle method, and in the log context we are pushing the property and then logging the information, and then we are getting all the users from in the repository. We have a get user method, and it gets all the users which currently have some item in their carts, and through it loops through all the users, and for each user it gets the basket or customer basket class, and then it updates the price in the basket. So here in the event we have received the product ID, the new price and the old price as part of the event, and we pass in the basket which we have to update. And then we have in the basket we check whether there are items which match to this product ID. If it does, then we loop through it for whatever items we are updating. If the unit price is same as the old price, then we update it to the new price, and then we put the current price whichever it was having to the old price of the object. So this way it is updated that the current price is the new price, and whatever was there earlier it's overwritten to the old price property, old unit price property of the class, and after that it is updated in the basket. So this way for whichever users are there, it is updating the price. So this is our event handler, and now we have to set it up so that it is invoked when we have this event. So for that, let's come to program.cs, add EventBus and enable. So whenever we need a integration event handler for this particular event, then we will initialize product price changed integration event handler. So that dependency we have set up, and let's go to program.cs, and one more thing we need to do is to set up the subscription. So for that we have another setup. We'll add another method in our app extensions which is to subscribe events, and we get the EventBus service, and then we call the subscribe async. So we are setting up the subscription where for this event, product price change integration event, the event handler is of this type. And we have already set up that dependency that for this type of product for integration event handler, what is the actual class to be instantiated. Now if we come to this method in our, so this is implemented by our service bus EventBus class which we had looked upon earlier. So when it calls subscription async, it just checks whether it already has an event for that type. If it already has, then it just adds that event to the subscription manager. But if the subscription manager didn't have an event for this case, then it creates a rule on the topic. So rules are different criterias which you can put on the topic, based on which the appropriate event handler can pick up the message. So what happens is whenever you publish to the topic, that message goes to every client. So it's the responsibility of the client that which message it wants to process and which it doesn't want to process. So here it creates a rule where the topic name is name of the topic which we had created, eShop EventBus, and the subscription name is the subscription client name. So in case of basket API, it would be, for example, basket, which we will use. And then we have a rule option where we are creating a filter with that the subject has to be equal to this event name. So here it kind of removes the suffix integration event suffix in her class name, and whatever remains is taken as the event name, and it creates a filter based on that. And if you come to publish, you can see that a similar mechanism is used for publish as well. So in publish also we remove the integration suffix and just create an event name, and that is what we put as subject name, so that there is a match between the subject being sent and the subject being captured or subscribed. So that way it creates a rule on runtime if that rule is not already created. After that, it adds that event handler. So you could have multiple event handlers for the same event in the same service if they want to do different things, and whenever that subscription is added, those would get triggered. So I think with this we have implemented all the changes we need, and I hope I didn't miss anything. Yeah, I did miss something, that is to call this just before. So let's call it app.subscribe event async, and after that it wouldn't let me do this, so I'll call it async, which is an extension method created here which internally calls run async but also puts some additional log informations for tracking. Now with this done, I think now we are good to run this. But before that, we have to make changes in our EventBus. So let's come back to our EventBus and add our first one, let's call it basket. That's what we need. The rest of the things we can keep it as is. The basket subscription is created. Let's add two more. One we will call catalog, which is for catalog service. We don't have any subscriptions there, but then we can always create. And let's create one more, say assuming we had an order API as well, which is taking care of the orders, and if we want that service also to capture, so this one we don't have a client for that to pick up this subscription, so we'll use this to check the messages which are coming in. So now this is done. The last change we have to make before we can run this is to make changes in our compose file. So if you remember from the previous videos, so Docker Compose is what we use to build to run this multi-container app, which initializes all the required containers and dependencies. So here we have updated this compose file to handle the basket API as well, which uses Redis as its storage, and we have basket API. Now we have to make changes for our EventBus. So we don't have to make any changes here, but we'll have to add new configuration settings in the override file. So first let's add the subscription client name. So for our catalog API it is catalog, and for basket API it will be basket. But another thing we need is if we go to catalog settings, we need EventBus connection string. We need EventBus connection string, which will be our connection string. So for that, let's come to our EventBus again, and in our topic we have this option called shared access policies. We have the same option in the service bus namespace also at the parent level, but since we want only access to this one, we can use, so let's select manage as well. We need manage because it creates those filters in runtime, so we need the manage permission as well. And let's click on topic and copy the primary connection string, then come back to our project and paste the connection string. So with that, it should be able to access our EventBus and perform the operation. So let's run it and check it out. While we wait for this application to get started, here are the book suggestions with this video. The first one is Monolithic to Microservices, Evolutionary Patterns to Transform Your Monolith by Sam Newman. It offers a compelling and practical approach to understanding microservices and transitioning from monolithic architecture. Whether you are an experienced developer seeking to upgrade your skills or somebody looking to improve your organization's software development practices, it is a book which is a valuable resource that would inspire you to explore the benefits of microservices and an evolutionary path towards building scalable, resilient, and flexible software systems. The next one is a bit heavy one, Emotional Intelligence by Daniel Goleman. It's a transformative book that can positively impact both your professional and personal life. It explores the significance of emotional intelligence in achieving success and fulfillment. It's backed by scientific research, and it will empower you to navigate the social dynamics, improve decision making, and also enhance your mental well-being. It takes time to grow upon you, but will be worth the effort. So enjoy reading. The services are up and running. So let's first add an item to the basket. So for this user, we have one item in the basket with the price at 19.5, and let's just cross check the item. So we have the user with one item in the cart. Now let's go back to catalog API and update the price. So we'll just change it to 25.5 and execute. Let's first verify if the price is updated. So you can see the price is updated here, and let's come back to basket API and verify our basket. So now we can see the price is updated in the basket as well. Now if we come to our EventBus, so we remember we had created one more subscription client order for which we don't have any services listening to it. So we can see that it has one message available. There's nothing in basket because that's already consumed and processed by basket API. So if we come to the order option and just check in the Service Bus Explorer, you can see one message is here where the new price is 25.5 and the old price is 19.5, and this is what was sent to basket subscription as well, and it was consumed by the basket API. So this way we can implement EventBus to establish communication and asynchronous communication between our microservices. Well, this pattern is not restricted to just microservices. You could use for any different components you want to make asynchronously connected, where like in catalog API it was just publishing the message and it didn't care whether it was getting processed or not, and other services could process that message at their own convenience, so there was no dependency and the components were decoupled. I put the link to the source code in the description box below. You can check that out. I've also added some reference links which you can check, which can help you understand it better. So that brings us to the end of this exciting topic about microservices. I hope you have liked the video. Let me know your feedback and comments in the comment section below. Thanks for staying till the end. You can watch something interesting next here. See you there. Till then, adios.